The Supergun. Project Babylon. A shell the size of a small car fired from a barrel so massive that it took over 4,000 men just to operate the gun. This isn't science fiction. This actually happened. And what you're about to discover will completely change how you think about the limits of human engineering. Let's start with something that sounds like it came straight out of a spy movie. Project Babylon. The year is 1988. Saddam Hussein, the leader of Iraq, has a problem. He wants to be able to strike Israel and Iran without using aircraft. He wants something that can launch shells hundreds of miles, maybe even put satellites into space. So he reaches out to a Canadian engineer named Gerald Bull. Now, Gerald Bull wasn't just any engineer. This man had been obsessed with superguns his whole career. He'd worked on projects in Canada and the United States, trying to prove that you could build a gun so large and so powerful that it could replace rockets for certain missions. Most people thought he was crazy. The military moved on to missiles and aircraft, but Bull never let go of his dream. When Saddam approached him, Bull saw his chance. Iraq had money, Iraq had resources, and Iraq didn't care about international opinions. So Bull designed what he called the Babylon gun. The specifications were absolutely bonkers. The main version, called Big Babylon, was supposed to have a barrel that was 1 meter in diameter, 1 full meter. To put that in perspective, that's wide enough for you to crawl inside. The barrel length? 156 meters. That's longer than 1.5 football fields. The entire gun would weigh about 2,100 tons when fully assembled. The shells it was designed to fire weighed 600 kilograms each. The range? Bull claimed it could fire shells over 600 miles away and possibly launch 400-kilogram projectiles into space. Think about that for a second. A gun that could put objects into orbit, not a rocket, a gun. So Bull started building it. He ordered the barrel sections from manufacturers in the UK and other countries, telling them it was for petroleum pipeline equipment. Nobody suspected a thing at first. The barrel sections started arriving in Iraq. Workers started assembling the massive steel tubes on a hillside. But then things went wrong. Intelligence agencies caught on to what was happening. Countries that had manufactured the parts were embarrassed and angry. They'd been tricked into helping build a weapon. International pressure mounted on Iraq. And then, in March 1990, Gerald Bull was assassinated outside his apartment in Brussels. 5 shots to the back of his head. Nobody knows for certain who killed him, but theories range from Israeli Mossad to Iraqi agents who wanted to silence him. Project Babylon died with Bull. The partially completed barrel sections were found by UN inspectors after the Gulf War, lying on a hillside in Iraq, rusting and abandoned. The supergun was never finished. It never fired a single shot. But it remains one of the most ambitious and insane gun projects ever attempted. But the thing is, even if it had been completed, experts today seriously doubt it would have worked as intended. The pressures involved in firing something that large would have been immense. The barrel probably would have worn out after just a few shots, and the accuracy would have been terrible. You can't aim a gun that's embedded into a hillside. Once you build it, it points in one direction, and that's it. Any enemy would know exactly where it was and could destroy it easily. But still, the audacity of even trying to build something like this is mind-blowing. A gun barrel longer than a football field. That's the kind of crazy ambition that defines this whole list.
Landkreuzer P.1500, monster. Now, let's talk about something that never even got to the stage of being partially built, but was so insane that it deserves to be on this list just for existing as a serious proposal. The Landkreuzer P.1500, monster. In 1942, Germany was already working on massive tank designs. They had the Maus, which was the heaviest tank ever built, weighing about 188 tons. But some engineers at Krupp, the German manufacturing company, thought that wasn't crazy enough. They wanted to go bigger, much bigger. So they designed the Monster. This wasn't a tank, this was a land battleship. The entire vehicle was designed to be 42 meters long and weigh 1,500 tons. Yes, you heard that right, 1,500 tons. For comparison, a modern M1 Abrams tank weighs about 60 tons. This thing would have been 25 times heavier. But here's the really insane part. The main weapon wasn't a tank gun. It was a naval gun, specifically the same 800mm Schwerer Gustav gun that we'll talk about in a minute. They wanted to mount this absolutely colossal artillery piece onto a vehicle and drive it around. The 800mm gun fired shells that weighed 7 tons each. The gun itself weighed over 1,300 tons. So the basic concept was to build a vehicle heavy enough and strong enough to carry this gun around. The Monster would have been powered by multiple submarine diesel engines, producing around 16,000 horsepower combined just to move this metal mountain. The design included 2 secondary turrets with 150mm guns, multiple anti-aircraft guns, and a crew of over 100 people. That's right, this tank would have required more than 100 crew members to operate. It would have been like a moving fortress. But there was one small problem. Actually, there were lots of problems. First, this thing would have been so heavy that it couldn't cross any bridges. The ground pressure would have been enormous, meaning it would sink into soft ground. It would have been incredibly slow, probably moving at less than 10 miles per hour on good terrain. It would have consumed fuel at a staggering rate, meaning it couldn't go far without refueling. And most importantly, it would have been a gigantic target. Any aircraft could spot it from miles away. Bombers would have had a field day trying to destroy it. There's no way to hide something that massive. Albert Speer, who was Hitler's Minister of Armaments and War Production, looked at this proposal and basically said no. He canceled the project in 1943 before any work had really begun on building it. Even the Nazis, who loved their crazy wonder weapons, thought this was too impractical. But the fact that serious engineers at a major company spent time designing this tells you something about the mindset during World War II. Bigger was better, more powerful was worth pursuing. Never mind if it made practical sense.
800-centimeter railway gun, Schwerer Gustav and Dora. Now we get to the big one. Literally. Schwerer Gustav and its sister gun Dora are the largest artillery pieces ever used in combat. Not proposed, not partially built, actually constructed, actually deployed, and actually fired at enemy targets. To understand these guns, we need to go back to the 1930s. Germany was rebuilding its military after World War I. Hitler asked his weapons designers to create a gun that could destroy the fortifications of the French Maginot Line. These were massive concrete bunkers and underground fortresses designed to be nearly indestructible. The French had built these fortifications with walls and ceilings several meters thick, made of reinforced concrete. Normal artillery would just bounce off. So Germany needed something special. They needed a shell heavy enough and powerful enough to punch through meters of concrete and steel. Krupp took on the challenge, and their solution was to build the biggest gun the world had ever seen. The gun they created had a caliber of 800 millimeters. That's 80 centimeters, nearly 3 feet across. The barrel was over 32 meters long. The entire gun weighed 1,350 tons. Let me say that again, 1,350 tons. The whole assembly was so large that it had to be built on site and transported on a special railway system with 2 parallel tracks. To move and operate this gun required a crew of 250 soldiers just for the gun itself, plus over 2,500 additional personnel for assembly, logistics, security, and maintenance. It took approximately 3 weeks to set up the gun at a new location. 3 weeks! You couldn't just roll this thing up and start shooting. You had to lay special railway tracks, assemble the gun piece by piece using cranes, and then zero it in on the target. The shells came in 2 main types. The high-explosive shells weighed nearly 5 tons. The armor-piercing shells were even heavier at 7,100 kilograms, 7 tons. Each shell was so large that it had to be loaded using a special crane system. The gun could fire these massive shells up to 47 kilometers away for the heavy armor-piercing rounds and up to 37 kilometers for the lighter high-explosive shells. The muzzle velocity was around 820 meters per second. When this gun fired, the blast was so powerful that anyone standing too close without ear protection would be permanently deafened. Now, here's where it gets interesting. 2 of these guns were actually completed. The first was called Schwerer Gustav, named after Gustav Krupp, the head of the company. The second was called Dora, and the name's origin is less clear, though some think it was named after the wife of a senior engineer. Schwerer Gustav was first deployed in 1942 during the siege of Sevastopol in the Soviet Union. The Soviets had heavily fortified this city, with underground ammunition depots built into solid rock and massive concrete bunkers. German commanders thought this was the perfect opportunity to use their superweapon. The gun was transported by rail, and the assembly process began. It took thousands of workers and weeks of preparation. But eventually, Gustav was ready to fire. And fire it did. Records show that Gustav fired 48 rounds during the siege of Sevastopol. The results were devastating. One shot reportedly destroyed an ammunition depot that was buried 30 meters underground. The bunker was built under a bay, protected by water and solid rock, and the massive shell still managed to penetrate and detonate inside. Another shot destroyed a coastal artillery battery, blowing apart guns and fortifications that were protected by thick concrete. The psychological effect was probably as important as the physical damage. Imagine being a Soviet soldier and seeing shells the size of cars falling from the sky. The sound of the gun firing could be heard from dozens of kilometers away. The ground shook with each shot. It was a weapon designed not just to destroy, but to terrify. But here's the thing about Schwerer Gustav and Dora. They were incredibly impractical. The amount of resources needed to build, transport, set up, and operate these guns was enormous. For those 48 shots at Sevastopol, Germany had tied up thousands of men and countless tons of steel and resources. The same resources could have been used to build dozens of normal artillery pieces that would have been far more flexible and useful. The guns were also vulnerable. They could only operate where there were railway lines. They needed weeks to set up, meaning the target had to be stationary and the area had to be secured. And they were massive targets themselves. If enemy aircraft spotted them, they could be bombed. If enemy forces advanced, the gun would have to be disassembled and moved, which took even more time. Dora was deployed to Stalingrad in 1942, but by the time it was ready to fire, the military situation had changed and it wasn't needed. It was sent back without firing a shot in combat. Later in the war, as Germany's situation became desperate, both guns were destroyed by German forces to prevent them from being captured by advancing Allied troops. Schwerer Gustav was blown up in 1945. Dora met a similar fate. Today, only a few parts survive in museums, but the legend of these guns lives on. They represent the absolute peak of railway artillery and the largest guns to ever fire in anger.
Nothing larger has been built since, and nothing larger ever will be. Because modern warfare has moved on. Missiles and aircraft can do the same job with far less hassle and far more flexibility. But as pure engineering achievements, these guns are incredible. The precision needed to build a barrel that large and that accurate is mind-blowing. The mechanisms to load 7-ton shells and fire them accurately dozens of kilometers away required solving problems that had never been tackled before. Like them or hate them, Schwerer Gustav and Dora were marvels of engineering.
42-centimeter HAUBITZE, M-GERÄT, Big Bertha. Before Schwerer Gustav, there was Big Bertha. This gun is famous, and its name became synonymous with massive artillery. During World War I, the German army faced a problem. The Belgian forts at Liège were blocking the German advance. These forts were modern, built with reinforced concrete and steel, designed to withstand artillery fire from the standard guns of the day. Germany needed something bigger. Krupp once again stepped up. They had been developing a massive siege howitzer, and they brought it to the battlefield. The official designation was the 42-centimeter M-GERÄT, but soldiers started calling it Big Bertha, supposedly after Bertha Krupp, a member of the Krupp family that owned the company. The name stuck, and it became one of the most famous artillery pieces of World War I. The caliber was 420 millimeters. The barrel was about 5.6 meters long, which is short for such a large gun. But that's because it was a howitzer, not a long-range gun. Howitzers are designed to fire at high angles, lobbing shells in an arc, rather than firing directly at targets. The gun weighed 43 tons, which seems almost reasonable compared to the monsters we've talked about so far. But in 1914, this was absolutely massive. It had to be transported in pieces by rail, then assembled on site. The assembly was done on a prepared platform, and the gun had to be carefully positioned and stabilized. The shells weighed about 810 kilograms each. These were high explosive shells designed to destroy fortifications. The range was about 9 kilometers, which isn't huge for artillery standards, but for a siege gun, it was enough. The gun didn't need to fire from far away. It needed to fire shells that were powerful enough to destroy the target. When Big Bertha fired, the effect was devastating. The first fort at Liège was hit repeatedly. The massive shells would arc through the air and come crashing down on the fort's concrete dome. Each hit would shake the entire structure. Dust and debris would fill the air. The defenders inside would be thrown off their feet. After several hits, the concrete would crack. Then it would shatter. The shells would penetrate into the fort and explode inside, destroying equipment, collapsing tunnels, and killing the defenders. One by one, the Belgian forts fell. The psychological impact was huge. The Belgian soldiers had believed their forts were impregnable. Modern concrete fortifications were supposed to be able to withstand anything, but Big Bertha smashed through like they were made of cardboard. The Germans built several of these guns, and they used them throughout World War I. They deployed them not just at Liège, but at other fortifications, including French and Russian positions. Wherever there was a tough fortification that needed to be destroyed, Big Bertha was called in. But the gun had problems. The immense pressure and heat of firing such large shells wore out the barrel quickly. After firing about 300 rounds, the barrel would be so worn that accuracy suffered and the gun became dangerous to operate. The barrel would have to be replaced, which was a major undertaking. The gun was also slow. It took hours to set up and prepare for firing. It couldn't be moved quickly if the tactical situation changed. And like all massive guns, it was vulnerable to counter-battery fire. If enemy observers spotted where the shells were coming from, they could call in their own artillery to try to destroy Big Bertha. Despite these limitations, Big Bertha was effective at its job. It proved that even the most modern fortifications could be destroyed given enough firepower. After World War II, Big Bertha was obsolete. Newer guns had been developed, and the Germans had moved on to even larger weapons, like Schwerer Gustav. But Big Bertha's legacy lived on. It had shown that bigger guns could solve seemingly impossible military problems. And its name became famous worldwide, used to describe any large gun or cannon, even to this day.
British 18-inch naval gun Mk1. Now, let's switch from land to sea. Well, sort of. The British 18-inch naval gun Mk1 is a strange beast. It was designed as a naval gun meant to be mounted on battleships, but some versions ended up on land, serving as coastal defense and even railway guns. To understand this gun, we need to understand the naval arms race before and during World War I. Britain and Germany were competing to build the most powerful battleships, bigger ships with bigger guns. The British had been dominant at sea for centuries, and they weren't about to let Germany overtake them. British naval designers kept pushing for larger guns. They went from 12-inch guns to 13.5-inch, then to 15-inch. But some designers wanted to go further. They wanted an 18-inch gun, which would be the largest naval gun in the world. The 18-inch gun had a caliber of 457 millimeters. The barrel was about 18 meters long. The entire gun with its mounting weighed around 150 tons. This was designed to be mounted on a battleship, where it could fire at enemy ships from a distance. The shells weighed about 1,400 kilograms. That's 1.4 tons. The gun could fire these shells over 30 kilometers. The idea was that a battleship equipped with these guns could destroy enemy ships before they even got close enough to fire back. The British built several of these guns, and they were actually mounted on a battleship called HMS Furious. But here's where things get interesting. The British quickly realized that 18-inch guns had serious problems. First, they were so heavy that only the largest ships could carry them, and even then, you couldn't carry many. HMS Furious only had 2 of them. Compare that to other battleships that might carry 8 or 10 smaller guns, and you start to see the problem. Fewer guns meant fewer shots, which meant less flexibility in combat. Second, the recoil was enormous. When the gun fired, the entire ship would shake. The stress on the ship's structure was immense. The British had to heavily reinforce the areas where the guns were mounted, which added even more weight. Third, the guns were less accurate than smaller weapons. The massive shells and enormous powder charges made it harder to achieve consistent muzzle velocities. Small variations in the powder or shell would translate to big differences in where the shell landed. And finally, the rate of fire was slow. Loading a 1.4-ton shell and the corresponding powder charge took time.
The gun might fire once every 2 or 3 minutes under ideal conditions. Meanwhile, smaller guns could fire much faster. The British Navy decided that 18-inch guns weren't worth it. They went back to 15-inch and 16-inch guns for most of their battleships. These were a better balance of power, weight, and practicality. But the 18-inch guns that had already been built didn't go to waste. Some of them were removed from ships and mounted on land. They were placed at strategic coastal locations to defend against potential naval attacks. One of them was even mounted on a railway carriage, creating a railway gun similar to the German weapons we talked about earlier. The railway version could be moved along Britain's rail network and positioned to defend different areas of the coast. The gun would be set up on a prepared section of track where the recoil could be absorbed by the rails and the surrounding support structure. It could then fire its massive shells at enemy ships that might try to attack. These land-based versions saw limited use. During World War I and World War II, they were more of a deterrent than anything. The enemy knew these guns were out there, which made them think twice about naval operations in those areas. One interesting detail is that when these guns fired, the blast was so powerful that it could damage nearby structures. There are stories of windows being blown out in buildings hundreds of meters away when the gun was test-fired. The crew had to take special precautions, and observers had to stand well back. After World War II, the 18-inch guns were retired. They were too expensive to maintain, and like all the other superweapons on this list, they had been made obsolete by aircraft and missiles. Today, a few survive as museum pieces, silent reminders of the days when navies competed to build the biggest guns possible.
Paris gun. Finally, let's talk about one of the most bizarre artillery pieces ever created, the Paris gun, known in German as the Paris-Geschütz. This gun is fascinating not because of its size in terms of caliber, but because of what it was designed to do. In 1918, Germany was looking for ways to strike at the heart of France. Paris was about 120 kilometers from the front lines. That's way too far for normal artillery. Even the biggest guns of the day could only fire maybe 20 or 30 kilometers. But German engineers asked themselves a question. What if we could build a gun that could fire all the way to Paris? The answer was the Paris gun. This was a railway gun, mounted on a special rail car so it could be moved. But it was like no artillery piece that had come before. The gun started with a 380mm naval gun barrel, but then things got weird. The engineers added a smoothbore extension to the barrel, making the total length about 34 meters. That's longer than most railway cars. The barrel was so long and so thin relative to its length that it would actually sag in the middle from its own weight. The Germans had to support it with bracing to keep it from bending too much. The caliber was 210 millimeters, which isn't huge compared to some of the other guns we've talked about. But the shells were special. They weighed about 120 kilograms, which is relatively light. But they were fired with an enormous powder charge, giving them an incredibly high muzzle velocity. Here's where it gets really interesting. The Paris gun could fire shells over 130 kilometers. Let me repeat that. 130 kilometers, over 80 miles. To achieve this range, the shells had to be fired at such a high velocity that they actually left the Earth's stratosphere. These shells flew so high that they entered the thin upper atmosphere where there's very little air resistance. Then they would arc back down and land on Paris. The shell's trajectory took them up to an altitude of about 40 kilometers. That's higher than most weather balloons. The shells were flying so high and so fast that they experienced very little drag. This is how the gun achieved such incredible range. But there were trade-offs. The shells were relatively small, so they didn't carry much explosive. When they hit, they would cause damage to a building or kill people nearby, but they weren't going to destroy entire city blocks like the massive shells from Schwerer Gustav or Big Bertha. The accuracy was also terrible. At a range of 130 kilometers, the gun could only hit somewhere in Paris. The gunners couldn't aim at specific buildings or even specific neighborhoods. They would point the gun in the general direction of Paris, fire, and wait. About 3 minutes later, the shell would land somewhere in the city. From March to August 1918, the Germans fired about 350 shells at Paris from several Paris guns that had been built. The shells came without warning. There was no sound of approaching aircraft, no air raid sirens, just suddenly an explosion. People would hear the blast and then, a few seconds later, the sound of the shell passing through the air. The shell was moving faster than the speed of sound, so it actually arrived before the sound of its passage caught up. The psychological effect was significant. Parisians were terrified. They didn't know where the shells were coming from. At first, many thought they were being bombed by a silent aircraft high in the sky. Others thought it was a new type of weapon they'd never seen before. The French intelligence services worked frantically to figure out what was happening. Eventually, they figured out that the shells were being fired from a railway gun far behind German lines. French aircraft searched for the gun and tried to bomb it. The Germans moved it frequently to avoid being found and destroyed. They would fire a few shots, then pack up the gun and move it to a new location. The Paris gun killed about 250 people and wounded around 620 others during the months it was in operation. For the amount of resources Germany put into building and operating these guns, the military effect was minimal. Normal bombing raids or standard artillery would have been far more cost-effective. But the Germans weren't really trying to win the war with the Paris gun. They were trying to demoralize the French people and show off their technological superiority. In that sense, it had some effect. The mere fact that Germany could hit Paris from such a distance was shocking. However, there was a dark side to the Paris gun. On Good Friday, March 29, 1918, a shell hit the church of Saint-Gervais-et-Saint-Quentin during a church service. The shell struck a pillar, causing the roof to collapse. 91 people were killed and 68 were injured. It was the single deadliest shell strike of all the Paris gun attacks. The gun itself was fascinating from an engineering perspective, but deeply flawed. Each time it fired, the enormous pressure and heat would wear away the inside of the barrel. The shells were numbered, and each successive shell was slightly larger in diameter to account for the worn barrel. After firing about 65 shells, the barrel would be so worn out that it had to be replaced entirely. The barrel wore out so quickly because of the extreme pressures and velocities involved. The powder charge was enormous, and the shell was being accelerated to speeds that artillery shells had never reached before. The inside of the barrel would erode with each shot, changing the gun's characteristics. At the end of World War I, the Germans destroyed all the Paris guns to prevent them from being captured. Not a single complete gun survives. We only know about them from photographs, documents, and a few fragments that were found after the war. The Paris gun represents the extreme end of what you can do with conventional artillery. You can build a gun with a ridiculously long barrel, fire shells at extreme velocities, and hit targets very far away. But the trade-offs are severe. The accuracy is poor, the destructive power is limited, the barrel wears out quickly, and the whole system is expensive and vulnerable. After World War I, nobody tried to build anything like the Paris gun again. The development of aircraft meant you could bomb targets hundreds of miles away with much more accuracy and flexibility.
Later, missiles would make even aircraft look limited. Today, you can hit a target anywhere in the world with a cruise missile or ballistic missile with precision measured in meters, not kilometers. But for a brief moment in 1918, the Paris gun was the longest-range weapon in the world. It could hit targets farther away than anything else humanity had created. And that makes it worthy of being on this list.